now going to demonstrate the ClearPriority Operational Intelligence Platform. Not going greatly into technical detail, but showing you a genuine example of a monitoring application. We will start with the supervisory console, where the user can gain insight into all aspects of the operational intelligence monitoring activity. The application is web-based, and so it is easily accessed from desktop or mobile devices. So I'm starting now with the alerting dashboard of the console, where the user can see the alerts that are made visible after events have been collected from the system and correlated for alerts by the operational intelligence engine. These alerts are showing the actual and historic activity monitored in a private banking order processing system. The user has a complete panoramic view of the whole list of alerts produced by the system. Alerts that vary from high to low importance, allowing the user to focus their attention on what's really important and must be responded to with the highest priority. Of course, alerts can be grouped together so that you get a quick overview of what's really important. That's what we see on the lower part of this screen. Alerts also have an origin value that shows where the alert originates from, like a subsystem, for example. Here it is in the order processing broker. And on the top of the screen, we have another view of the distribution of the alerts by time, and we can see that we have around 5 alerts that still have to be processed at midnight on the 13th of September in 2012. We can also have other views where we change the timescales, e.g. by month, to have an alternative view on the number of alerts that have been detected. In this particular example, about the order processing monitoring, we are most interested in orders that haven't been processed as expected. There may be a service level agreement that's been agreed between several parties, such as the end customer, the bank, and the market, which in this case is a third-party broker. For instance, here we have an alert for a blocked order that has been transmitted to a broker, but the broker has not yet acknowledged it. This might mean that the bank is liable to pay a penalty to the customer if the transaction is delayed, such that today's price quotation cannot be respected. Another aspect of the supervisory console is the ability to manage the alerts that have been produced by the system. For example, I can just click on my Manage Alerts button. For example, I can just go in and note here that I'm starting some manual intervention on a specific subsystem to resolve some issue. We mark the alert as being open so that later on someone in my team can come back and continue fixing this particular problem. When I'm looking at the alert details, I can see a whole load of other information that enables me to better understand that alert. I was typing a subsystem number identifier here, showing where I would need to go to fix that particular problem. That information is gathered from various events that have been correlated together to show that some problem exists in the order processing system. So here I have the alert name and the system date and business time when this problem was seen. Later on, I can come back to my alert management and make a note that I've finished processing my manual intervention and then mark the situation as closed and that my order has now been processed correctly. Of course, for another processing system where you have many orders per hour, it's not really suitable to do it all manually. Therefore, you can configure ClearPriority to automatically close alerts by itself when appropriate. So, for example, where we have an order that was blocked, we can often see that there were following events that ClearPriority detected and that enabled the system to fix the problem without intervention, without manual intervention. Perhaps there was a temporary overload of the system, for example, but it was finally processed as expected, and so there was a slight delay, but ClearPriority was able to automatically close the alert by itself, and so a risky situation has now disappeared. Of course, you can also have details on these same types of alerts about where those alerts are coming from and if they are happening regularly. For example, here we have the same origin, so it's quite likely that that order has a similar problem to the last one. So I was talking about views on the alerting produced. What is also interesting is that you can have customized views so that and put them into pages, so that here, for example, we have 1, 2, 3, 4 different pages. Those pages can be saved for later retrieval and organised according to what is really relevant to focus on for the end users. Here I would like to have a view that is targeted more towards the underlying subsystems, whereas here I want to have a view that is focused only on the order processing itself, which in this case is the main business concern. Also, the ClearPriority platform offers indicators that are values computed by the monitoring system. And here I have a graph showing me that the average processing duration of a specific subsystem is that amount of time, and I can see the set of values that have been calculated along my timeline. If I click on different indicators, the other graphs are then updated. I can show more interesting graphs that show specific areas of interest, such as here, where we are showing the length of time between two specific steps in the order processing workflow. We can see that on average we are something like 30 seconds, but we have some peaks increasing up to 90 to 100 seconds, and maybe even higher where we have something like 110. So we have thresholds that can be applied to these KXIs that trigger alerts. Another interesting graphical representation is the traffic lights. Here we have a traffic light with 3 indicators that are combined, and these traffic lights can be modified, for instance, to show what's important, and it works by summing together the values of various indicators. So the weakest one here is in orange, and these traffic lights might be configured to give us a high-level indicators of the state of compliance, for example, of a given system or process, etc. Again, these indicators have views defined in pages which I can pre-configure and reload as required to give us some focused indicator pages. Also, we have many graph tags such that we can compare and overlay graphs, and for example here I want to compare the indicator on the left with the time it took to process the orders. So this gives me considerable flexibility in how I represent and view the situations I want to monitor. We also have in the supervision console an event dashboard which allows us to retrieve and view a whole series of events that we have captured by the platform. For example, here I'm showing the events related to the mapping and loading of external data inside the order processing system. And I can see that there were many errors due to internet or systems failures that were causing us grief and failures that have detrimental impact, of course, on our business. In the case of the order processing system, we are most interested in monitoring the processing path of orders, and here we can see the several different states that each order passed through during that process. So let's focus on a specific order to show the drill down capacity and follow that order in more detail. So here I was selecting the order that was giving me the alert earlier on, and I can retrieve information on the various states that the order passed through and the times that these states occurred. ClearPriority is connected to data sources, and here we have several sources such as the order workflow data stream, and we can see the systems these are based on. And in case we get late events, we will be able to review them in that kind of screen. But a well-tuned system, by the way, doesn't have any late events. We also have the opportunity, although we don't see any here, to see information coming in that ClearPriority doesn't understand to be an event and therefore doesn't use. So we can make sure that whatever we are mapping is always being used and not missed. To administer the system, we have an administrative console. So let's connect to this web-based application. It permits the user to install and manage monitoring applications, like you see here with a listing of monitoring applications already installed. We can see, for instance, that on this platform we have the order monitoring application to show us the state of health of that system, and we can see when it was started and by whom. We can configure various parameters to suit the environment where the application will be used. So if the operational parameters need changing, we just have to modify them here without having to redesign or amend the actual monitoring application itself. We also have the capacity to clean or purge the event data, which needs to be done regularly because if thousands of events are collected, maybe even per second, it would be useful to clean up those that didn't trigger alerts. So rather than clutter up the database, the administrator can get some timeouts to remove information that isn't needed anymore. We can also configure some automatic alert closing policies so that if alerts are not managing in the timescale that is useful, they can either be escalated. So if an alert isn't dealt with quickly, it can be escalated, or it can be discarded silently if there's just too many or they're too low level importance to deal with. Also, this is useful when doing acceptance testing and applications testing. You can also specify external alerting rules so that, for example, for a specific alert, you can choose who should be alerted, maybe sending a message to their desktop or to social media even. We can also define the physical and logical source mappings here, so that data sources for a monitoring application can be linked to a logical source. So for example, here we can see that my order workflow monitoring application is linked to this specific logical source, and that's linked to a specific physical data source. It means that the application is totally transportable from one environment to another, just by remapping. Over here we also manage the permissions. So here we have someone who is supervisor for 4 monitoring applications, and you can select and deselect who can see which monitoring application. And so you can have the same platform used by multiple users for different purposes. Also, these types of parameter might be of interest because our platform is designed to be easy to integrate inside an enterprise environment. So you can configure the domains and names and the LDAC Active Directory settings, for example, as required. You can configure over here the communication with external systems. For example, ClearPriority might send an alert to an IT monitoring system and then await and listen for a response that would allow it to automatically close an alert once the external system has resolved the problem. And over here we have some of those parameters that can be cleansing and automatic closing parameters for the whole platform. So far then, what we've done is we've been through the supervisory console and a wide range of capabilities for monitoring and alerting abnormal events to ensure the correct processing of an order in our private banking order processing monitoring application. In this final part of the demo, we're going to add in a new rule to show how we would monitor a particular situation where there is a risk due to a cut-off time for processing transactions. Remember that if orders made by traders are not processed by the cut-off time, let's say 1600, 4 o'clock, then it might not be possible to process them on the same day, and the agreed quotation price may not be honoured. In this case, our bank may be penalised by the customer. So we will use the ClearPriority development console to create a new rule that we can add to the current monitoring smart pack to extend its monitoring to alert us to this new risk situation. We will use an external event, in this case the cut-off time, which is correlated with the internal processing of the orders, to check for problems. So here we have seen previously that we have 4 applications. What I will do is create a new application which will take a copy of the existing rules and add in the new risk monitoring scenario. Let's call it Cutoff Monitoring App. I will start at version 1.0. Versioning means that if the application is running against a live event stream and some problem occurs, it would be easy to downgrade to an earlier version of the monitoring smart pack and carry on. So now the system is duplicating the configuration. Takes a little time. Here is my main modelling environment, where we monitor risk or opportunity scenarios that the system has to detect and create an action consequent to that event. So let's start by creating a rule. By clicking this button and giving it a name, like cutoff rule, and here I will have my main modelling area, where we have to express the pattern that has to be detected, showing how the situation has to be evaluated, as well as what the action is that the system has to take when it finds that scenario. So let's start by detecting a situation. So what I'd like to detect is the occurrence of an order, which is an order ready to be sent to the broker made by the trader. I can reuse the existing order type, so here I already have an order status type. So I will detect that I have an event called order status with the state of ready to send. We have a ready to send order. I would also like to detect that I haven't received any order acknowledgement by the third party to say that this has been processed. And this also has an order status type. And here I have all my attributes that we saw previously, like the operation code and so on. I would also like to ensure that I don't create any false positives in case I get an acknowledgement a bit later on, and so I will wait a maximum of 5 minutes before raising an alert. This means that if an order is placed by a broker and the order isn't acknowledged within 5 minutes, then the pattern, the event, is detected. And I can also verify that the operation codes of the two events match each other, otherwise we would capture the wrong event. Okay. This is now my detection pattern. Now I would like to evaluate the situation, and I can do that quite easily by simply looking at the time left to react before the cutoff time. The time left to react is actually the difference in minutes between the time of the cutoff for that bank, say every day at 4 o'clock, and the time of issue of that order. I would like to know if, when the order is issued by the trader, the difference is within my limit. So we use here one of the functions on the left. Functions are small snippets of logic that you can use in your rules to determine situations that you can act on. So here I would like to detect that at a minimum we have 15 minutes left. Now let's make that 30 minutes. So when a trader creates an order in the order processing system and the order hasn't been acknowledged within 5 minutes, and we are at a minimum of 30 minutes before our cutoff time, then we need to raise an alert to this risk scenario. As an action, what I would like to do is to make sure that I'm informed of this risk situation. So I create an alert, which we'll call risk cutoff alert. The alert will be typed as well, so it's typed. We type in its type here, and of course we could add some more attributes, but we won't bother to do that as this is just a demonstration. As an origin value, I would like to retrieve the operation order code so that the person doing the monitoring will be able to react. They'll know which order to go and look at. I will also select a high level. It's important that I get this alert, and also make it totally active. So I think we are now all set, and we save the monitoring application inside our repository. The repository that is stored on the ClearPriority system so that we can work with multiple users on your applications. I am also able in the more detailed editing to describe what is the problem we have just created a rule for. So here we could say that this includes the detection of cutoff. And what would be the expected reaction of the team if they find this alert, they're given this alert, would be to verify by phone with the broker that the order was properly received and will be duly processed that day. Okay, we are done. So let's validate the whole thing first, so that the system verifies there are no inconsistencies in the rules, and then we build the application when it's verified. So what it's doing now is building the app and creating the executable file that will enable me to implement it on the runtime platform. So it is being generated, and the speed of this generation depends somewhat on what system, what program, or computer you're running on. Here we are. I can do this on my own computer, so that I can transfer the executable using any media, file transfer, email, or even a USB stick, and store it on the required segregated area. It could be useful for testing or production environments, etc. So now I go back to my administrator's console. I now add my new application onto the existing one. So behind the scenes, the system is going to create all the data structures in order to understand and correlate and process the events and maintain the data captured. Okay, so now the monitoring application has been loaded onto the system and is being processed. Then I just have to map or connect my monitoring application onto the physical resources that is actually my flow of orders processed by my order processing system. Now it is connected, I have to add my user permissions and then start my application so that it starts monitoring the event stream. Now the application is being run by the system. I will go back to connect my supervision console so that we can see what's happening. So I shall retrieve the tabs that I had before and create a new tab, and I will select only the alerts that were collected by my new application, and then look specifically at the alerts created based on the cutoff aspect. So we start off with no alerts, and now I manually create an order in the order processing system that is timed at 3:40, which is 20 minutes before the cutoff time. So now the system will be sending that order, and ClearPriority is going to capture the event information and evaluate it to see if it's an alert scenario because of the time pattern being detected. So we'll go back in a minute and refresh this page and check in the event list first to see if the event was captured. And looking back into the supervisor console for our monitoring application, we should have an alert. Here is my new alert. So what we've shown is how easy it is to add additional alerting rules and logic into an existing monitoring application by using the development console to model the scenarios and defining the evaluation criteria and the actions required when alerts are raised. Alerts can also be used to create new indicators or new events that feed into the event stream so that maybe the system can inform other smart packs of events that they might need to correlate and evaluate for abnormal situations. And that's the end of our demonstration.